So it says it's recording, but it didn't say anything. It's just, okay, is this vector a linear combination of these vectors? Now, I usually won't say of this form. You should know the form. Linear combination. Okay. This is really important, really pretty simple. The stuff that's coming up, especially next week, coming up already for linear assignments. Okay. Well, you want to see. If this equation has a solution, because that's what it would mean for this to be linear combination of these. This linear combination equals this. I think most of you got that. Maybe you already got that. That's good. Okay. All right, so we can translate that to okay. The short answer is no. The equation translates, didn't get to finish that word, to translates to an augmented matrix of this form. That translates an augmented matrix, and you reduce it, comes down to this form. This thing over here isn't zero. And this, of course, means that x 0 equals something that isn't zero. 0x1 plus 0x2 plus 0x3 equals something that isn't zero. But 0 can't equal something that isn't zero. So it doesn't happen. Okay? So our details. The system is right here. System. And I just say et cetera, because everybody was reducing the matrix and was going to see that This is what you end up with, right? Okay. So I'm not going to go into details of this. Everybody should be good with this system of translating things, and that's an achievement. Okay, doing that, that's pretty good. If you're not doing it, you really got to get it done. Okay, because you're going to need it. That's it. Now they're right. Okay, it's really kind of a central question. As you will see. Okay, well, anyhow. But I think people are in reasonably good shape. I can go on a little bit with this. An extended question. Does this equation have a non-trivial solution? Okay, by trivial solution, I mean, obviously C1, C2, and C3 are all zeros, and it's going to be so, right? But with a C1, C2, C3 that aren't all zero, you can see that this equation would lead to the same matrix, except you'd have zeros over here, right? So you get this augmented matrix, right? And it was reduced. But now you're going to have a zero over here because there's nothing you can do. Adding multiples of zeros to zeros doesn't change the fact that you got zeros. So that this matrix is going to reduce down to a matrix like this, but you're going to have zeros over here. Okay? Now, what's that going to do? Well, that's going to lead you to a free variable. Okay, let x3, let's say, equal t. Right? So this variable is equal to t, which then gives you the value of this variable. It's going to equal, well, again, this is going to be a zero here, right? Okay. And now you've got the values of these two variables, so you get this. Okay, just by back substitution. You have an arbitrary variable, free variable, that gives you an infinite number of solutions. Okay. Infinite number of constants, combinations of constants. Now they all have a structure, but it's an infinite number. And this just means that one of these vectors is a linear combination of the others. At least one, okay? Because of course I could rearrange this equation to put the C3V3 over here, and you can see what the augmented matrix is and what the system is, and what that does to your solution, okay? And you would have solutions. Again, an infinite number of ways that would work. Well, I don't have room to write out. I'd like to write out, so I'll leave it at that. And we'll clarify that a little bit. Okay, so there it is. This is going to be kind of a lot of what we do for the rest of the day. But let's go back and get the subspace. Okay. Because I'm kind of introducing subspaces with the problem. Well. Here are the questions for reference. So we have this. Now, we want to test closure. I'll just say closure for the form, just to make sure we're identifying this. Okay. If you have closure comes down to the question is V plus W in the space? Focus on that. A lot of words that go around that. Make sure you understand the words. If you understand that this is what you got to ask, then the words make sense. If you don't understand the words, you don't understand this, then you're not ready to prove it, okay? Not ready to test closure. And you will be in a couple of minutes, okay? It's very simple. I did it last time, but and it's new and it's only been 2 days. It hasn't had time to sink in. And apparently the web assignment, somehow everybody made a perfect score on it without understanding it, okay? But you've got to be aware that you can do this. Now, your test is, can you come in and answer a fairly basic question that you should be able to answer if you've digested the material, okay? Now, you digested the material for that last question that we just did, which was due last time, okay? So, you know, if you got digested by the next time you come in, that's okay, right? But make sure you get it digested, okay? And you will, I think, in doing this new section. Okay, so is V plus W in the space? Well, what do we mean by V and W? I mean, 2 matrices of this form, right? So we got to identify you can't read it, but you know what I'm saying, because I made sure the 0 was clear and I've got 4 numbers, right? Okay, so how am I going to write down? Two matrices. In general form, that means I don't write down 2, 3, 4, 0, and -1, -7, 5, 0. I don't make up numbers. I use symbols. General form means it could be any matrix. The numbers could be anything, okay? For example, you can use any notation you want to, okay? You could call one of them A, B, C, 0, and the other D, E, F, 0, okay? But sticking with the subscript notation, which is something you kind of want to use to. So for example, let B equal A11, A12, A210, and W equal D11, D12, D21, 0. These matrices could be any 2 matrices. of this form. Okay? No restriction. They're both of this form and they're both as general as they can be. If I put a 0 in for one of these, it wouldn't be of this form anymore because it wouldn't be a general matrix for that form. It'd be a little more specific. That makes sense? You want a general matrix, and this is, you know, this is a quick discussion that you probably like, maybe want to review. Okay? If you don't totally understand this. I think there's a good chance that you do, and will. But if you don't, I recommend clicking through this one, right? Other classes aren't doing that with the dog. I think y'all probably will. Okay. You probably need it less than they do, but everybody needs it. Okay, well, anyhow, there we go. Now, so the question is V plus W in this case. That means does V plus W also have this form, right? And you know what? Since the form uses A's, I kind of hesitated to use A's here. I couldn't think of a good reason not to because I wasn't thinking. I'm going to call this one C11, C1. Usually we go alphabetical order. Okay. Okay, then all we got to do is look at what V plus W is. And I don't have to write out, you know, V and W. You know what we get when we add these. You're going to have C11 plus D11. D12 plus D12. D21 plus D21. And you still got 0, right? And this is for the form. A11, A12, A21, 0. Well, A11 equals C11 plus D11. A12 equals C12 plus D12. And A21 equals C21 plus D21. In other words, if I have two general matrices of this form, they add up to a general matrix that also has this form. Now that's what you would need to write out to show that this is closed. It's not an intuitive, okay, it looks like it's closed, so I'm going to say yes. And that WebAssign says, yeah, you understand this now. No, you don't understand it. You made a good guess. Yeah, that's good. You know, you guessed right on all of them. Now, if you had to do two guesses, okay, then but WebAssign is pretty well set up. It's very specific about what properties this thing does and doesn't satisfy, right? So my question to you is, why is it you didn't pick that up? Well, I'll have to answer this question with some sort of sense. Now, in some cases, I did see, you know, a start of sense glancing. Like, for example, okay, we for 10 properties, this thing inherits, and then this one's true. Okay, right? It's good. If you know that this thing inherits a lot of properties, if you know that 10 of them doesn't, it means you weren't asleep. It means you learned something. Okay, so I'm not saying you did bad. I'm just posing the question of what can you do to do even better. Okay, and if you didn't even get a start on this, you know, ask yourself why not. Maybe because you had a lot to do the last 2 days. I really don't like having assignments due in 2 short days. That's why I give you longer assignment over the weekend. I think. Okay. Just an anecdote. Yeah, I did pretty well in my physics course. So I got to my 4th semester physics course, which is on waves, and I wasn't doing well. Professor, wonderful guy. He was an old guy. probably 10 years younger than I, but he's an old guy. Okay. And he might have been close to my age, maybe even my age or older. He had, among other things, he worked with Einstein. Okay. He collaborated with Einstein and stuff. He was a top-notch guy. He had this ornate office, large office. Very, very well appointed office. So I went up to his office and I said, Dr. Sankins, you know, I've done well in my physics courses. I just finished the electromagnetism course, like one of the highest grades. Okay. So I'm not totally stupid. I didn't really say that, but you know, it's coming. But I'm just having trouble with this because the assignments are due too quickly. I need a little more time for the assignments to sink in. What should I do? Well, I figured that, you know, about that point, he'd call security and have me thrown off the roof. Pretty reasonable. Okay. But as I say, it's a really nice guy. So, and he just sat up and said, well, it's not my intention to force people into a disadvantageous, I don't remember what his words were, but a disadvantageous form of learning. So you can have a week. And that's like you know, asking the Supreme Ruler for something that you think he's going to think is unreasonable and have him give you a really reasonable response. Okay. And I say that just to reinforce the idea that I understand that maybe some of these something to do with a little bit of short sleep, but still got to get as much out of it as you can. And if you don't get everything, you got to go back and look at it. Okay. Okay. Well, as it turns out, I still did nice. I'm not sure I even made a beat, but I got through it. Okay. Something mysterious about it. I don't know what it was. It didn't sit well with me. Okay. If I did make a B, I was close. And this back when I see was a good grade. Right now, she's like, I know. You know, the average of full institution was middle C on all courses. It's just grade inflation was just starting at that point. Hadn't really taken hold at that level. Okay, well, excuse the digression, but you understand my point, I hope. Try to absorb the meaning of your homework. The textbook communicates with wonderfully, but again, in 2 days, it's a lot to absorb. Make sure you continue absorbing this. Now, there's another way. Well, another thing you have to prove. CV is in the space. Now that means for C, an arbitrary scalar. And I'm not writing down all the words, but that's the idea. 2 things, V plus W has to be in the space, V and W, any old vectors have this form, right? And C times V, C any old number, V any vector this form. Well, obviously, if you multiply this by C, you're going to get CA11, CA12, CA21, and you're still going to get 0 there, right? But you've got to write that out. And you've got to make sure that it's very clear that you understand the things that you have to do. Okay? You haven't had to do things like this in your periodic course. Maybe a little bit in your first semester calculus. Okay? You might have had to actually prove a couple of things. Right? First semester calculus course, you get away from proof. Not sure who thinks that's a good idea or why, but Maybe it is. I don't know. Actually, I do, but I try to pretend and put on humble. Okay. Now, we can do the same thing with this matrix, with this form. What happens? Well, can you write down a V and a W that has this form? Let's do that for me real quickly. Should be able to write it down in about 30 seconds. Okay, now everybody did well writing down a couple of vectors of this form. Just be like this, except you have a V22 here and a 1 up here, right? Yeah, C22 here and a 1 here. I think everybody did that. If you add those, you get a form that has like A11, A21, A22, but what goes here? If you have, show me with your fingers. You have 2, right? And that 2 is a 1, is it? Okay. That's an important idea. Also, if you multiply this by 0, you don't get this form, do you? If you multiply by 0, you get all zeros, you don't have a 1 there. Okay? So I don't have a good place to write this. I'll kind of put it in here. Some arrows. Zero times V has a form. Actually, it is this vector. And there's no 1 here, right? So let's make sure we understand that applies for this problem, not this problem. Again, very important concept. Okay, set a polynomial of this form. Is this a vector space? Well, I'm going to ask you to go ahead and write me down 2 polynomials of this form, in general form, not with specific numbers for A and B, but symbols. So okay, everybody did that nicely. They did it quickly. I'm going to call this O1x squared plus B1x and A2x squared plus B2x. Some people use C, D, E, and F for coefficients, and that would be fine. Let's go work out. Okay. So that, okay, B plus W equals A1 plus A2 x squared. And, you know, so as not to confuse notation, I'm going to use a C1 and C2. In some ways, that C, D, E, F is not a bad idea at all. I mean, it was never a bad idea. It certainly has some advantages. And this is of form. Okay. Actually, probably wouldn't have been bad to use A because we had A equals A1 plus B1 plus B2. So you figure out the notation that you think communicates best. I would pick one that doesn't. Okay. But there's the idea. Also, just picking the B vector, you can see that this still has a form. It's a polynomial with a degree 2 with no constant over there. Okay. Now, it'd be interesting because this is a quadratic function. We should understand the whole theory of quadratic functions, but probably not. Because again, for calculus course, you got a lot of people who can't really learn it, so nobody's made them learn it in a way that sticks. So we're not going to get into that, but there it is. Okay. Well, what we just proved is that and you can read. So, matrices of this form are subspace, subspace with 2 by 2 matrices. Okay. Also, and now that's kind of a fancy P. That's P2. And that's a space of polynomials to degree 2. Okay, the leading coefficient is 2. I'm sorry, the leading exponent is 2. Okay. Now, spaces and subspaces can be understood fairly intuitively in terms of R2, the plane, coordinate plane, and R3, three-dimensional space. X here, Y here, Z. Okay. So let's say this, the set of ordered pairs such that, I'll write double on it, such that X is a real number. Well, that's what I want to say. give you a whole space for that. So such that, assuming X and Y are real numbers. Okay, well, that's sets at 2x minus y equals 0. Is subspace of R2. Okay. Now you can prove that. You might think how you prove it. You just let x1 and y1 be two numbers, arbitrary numbers that satisfy this equation. X2, y2, two arbitrary numbers that satisfy this equation. Okay. And prove that the ordered pair x1, y1 plus the ordered pair x2, y2 also satisfies the equation, which means that 2 times the quantity x1 plus x2 minus the quantity y1 plus y2 would have to be 0. Okay. Now, if it's true for the x1, it's true for the x2. You just add the two equations and you get the result. Okay, it's very easy to prove that. Now, your book proves it by parameterized. So I let t be any number, let y be t, so that x is 2t. So now you have numbers, ordered pairs of the form 2t, t. So if you got 2t1 and t1, 2t2 and t2, add them up, you get 2 times the quantity t1 plus t2, and then t1 plus t2. Now I've said that and recited it, but you can read it in your book. It's as simple and even a simpler situation in many ways than the ones we just looked at. Okay. So it's a subspace of R2. I have my word for that, but that subspace constitutes a line through the origin. If I've been able to hit the origin, okay, let's make a big origin here. Okay, now I hit it. You understand? It's a line through the origin. We need to do this geometrically. If I have this line through the origin and this line through the origin, and I add the two lines, meaning I take any x coordinate and I add the x coordinate of this to the x coordinate of this, which means that I've got this minus this, so it's here. Here's a point on the sum of the two lines. That line will also go through the origin because at the origin, both the y coordinates are 0. Okay? Make sense? Hopefully it makes sense. Now, again, people don't look at graphs and adding graphs geometrically. It's hard to teach them that, so we don't teach it. But then people have trouble with my course. You know, yeah, ridiculous. You don't have a picture of what these things mean, you don't really understand it. In most cases, and you're making people who understand in terms of pictures, you're gravitating them toward understanding in terms of symbols, which might not be as natural to them. And I do. In my humble, not so humble opinion. Okay. If the equation is 2x minus y equals 1, then your test for closure wouldn't work, just like it didn't work for the matrices when we had a 1 there. In geometric terms, both of the graphs would go through the point 0, 1, wouldn't they? Or actually 0, -1. Okay. So there, which means if you add them, they have to go through 0, negative. The sum has to go through 0, -2. Also, the multiple, if you multiply the coordinate pair by 0, you're going to get 0, and it doesn't satisfy this anymore. Okay. Well, your book tells you all that. That's important. Gets into the idea of affine spaces, which we don't do that much with, but it's a seed for something that can be extremely important in some applications. Okay. We're not going to talk a lot about it. I found it pretty confusing. I mean, I have this idea, but the definition of affine spaces is a little too abstract for me as a sophomore. Okay. I could do it with simple examples, but I didn't generalize a whole lot. So we're not, the book doesn't talk much about it. Now, I don't see a good reason to talk much about it. That is something that you kind of need to do a little more advanced to really. Okay, so a comment that this is a subspace also of R3. Okay. Now, in this case, this equation says nothing about Z. So Z could be anything at all. Saying this a little more quickly than I'd really prefer to. Okay. Here's your graph. In the XY plane. Okay, so all these points lie in the XY plane, so you can kind of do projection lines to show that they're in plane and they project to 0 on the Z axis. Okay. But Z can have any value. So this point is on the graph, but it's also on the graph if you have the same X and Y, but any number for Z. So for example, Z could be 1. So if this is 1, you can come up to here. Okay. This point still satisfies this if it's directly above a point on the line. So any point in three-dimensional space that lies above a point on this line is a member of this subspace. And it's easy to prove this is a subspace. You just, again, do an arbitrary x1, y1, z1, x2, y2, z2, okay? And prove the closure and stuff. Okay. So what we can do is we say, well, okay, so let's just make this into a plane. Too far with that, so here now we have at least a section of an infinite plane. All the points above the infinite line here, above and below. Okay. So and that plane is represented, or that subspace is represented by a plane in R3. And this is represented by a line in R2. In general, I can take any linear equation in X, Y, and Z. Linear equations, multiple of X, multiple of Y, multiple of Z, set of equal to 0. And it gives me a subspace, which of course won't necessarily be a vertical subspace or a horizontal. Okay. It could be linked at any angle, and you see a lot of that when you take molecular calculations here from that. If you're in art curriculum, you have differential equations in molecular calculations. And you would have different instructor for differential equations, which might be to but you have me for physics. Okay. And then in the spring, you probably have me for physics and molecular variable. because I think I'm gonna offer somebody else the opportunity to teach things out. We need to transition. I'll eventually retire, rapidly approaching middle age. Not inclined to do it right now, but if I sleep a little more, maybe. But don't slip. I don't know how long it'll be. How would I know if I'm slipping? Here we go. Okay. Now there's some stuff you need to follow up on linear combinations and so forth. So let me just take a quick peek. But anyhow. Okay, linear independence and spanning sets. If we go back to the problem we started with, which is this problem, we found that there's a vector that is not a linear combination of these three. Okay. So we can say a little more formula. It probably wasn't a linear combination of this set of vectors, okay? Those vectors that are linear combinations is a subspace of R3 because, of course, V1, V2, and V3 are vectors in R3. Meaning that the set of vectors that satisfy this have initial points at the origin and their terminal points are on some plane. So that this subspace could be visualized as a plane. I'm just going to say the same subspace can be expressed as the set of linear combinations of V1 and V2. I said a linear combination. The set of all linear combinations of V1 and V2. Okay. Now there are things to be proven about that. And it comes down to being able to deal with these augmented matrices and understand what they're telling us. span of any set of vectors is the set of all their linear combinations. So in this example, going back to the quiz problem, in this example, the set of all linear combinations of these three vectors is the same as the set of the linear combinations of these two vectors. You prove that by setting up equations and matrices, and the text will have examples. Okay. Okay, I kind of alluded to this earlier. If one of these vectors is a linear combination of the others, then you can solve this equation for C1, C2, and C3, not all zero. Okay. For example, if B3 is a linear combination of B1 and B2, we use B1 and B2 for the constants. Then have this. C1, B1, plus C2, B2, plus C3, B3 equals the zero vector. So C1 equals B1, C2 equals B2, C3 equal to -1. Again, say B3 is this sum, well, just subtract B3 from both sides and we get this. And that's a linear combination of B1, B2, and B3 that's equal to 0. You put it in this form, make it really formal. The same because this is satisfied if C1 equals this, C2 equals this, and C3 equals -1. Okay? Kind of important to understand that. You want to ponder that. Well, we're out of time. I'd like to say more. But you should be in reasonably good shape to understand what the text is telling you and to do the problems, because you're pretty good with those augmented matrices and systems and equations.